We're on week 6, set 3, SWYK 1. And the first, Math Excel is kind of weird. It requires, so I went out and I picked problems from this, for this particular SWYK and the next one that had questions which were in different math textbooks. It requires that I put one review problem in it. So this is obviously a review question. You're shifting this down 10 units. So you know you're going to be starting here. You got your A value of 1. You can do your 1A, 3A method of graphing. I'll let you handle that. Whoa, too fast. All right, now I want to talk about domain and range. Now we said that domain, we said that domain was going to be this. Why in the world? I'm trying to. Okay, so you know when technology is not your friend. We said that the domain on these is going to be negative infinity to infinity everywhere you go. Okay, because as you push all of the points down on the x-axis forever and ever and ever, you're going to cover the entire x-axis. So that's not the biggest of deals on these questions. What's really more important is what's happening with the range. Because if you start pushing all these points forever and ever and ever, you can see that this was shifted up 5 units. So all I did was sketch a graph of a parabola that's been moved up 5 units. Nothing major. What I want to look for is something that says 5 going to infinity, right? It has to include it. So there you go. Right down there is your range. What about this one? What's the range of this one? Well, you can see that it went right 3 and up 7. So you can see I just drew a quick sketch. And it is opening up, right, because of the positive 11. So if you start thinking about pushing all the points onto the y-axis, you would start at 7 and you would go up to infinity. So, you know, that's what you'd have. You ever notice that negative infinity to infinity kind of reminds you of the Marvel movie Infinity Wars? Okay, maybe just me. All right, so on number 4, domain. It says find the domain range of quadratic function whose vertex is -1, -3, and the graph opens up. So I just, sketched it. So now we're looking for, domain, negative infinity to infinity. I mean, look at this. Laughable. We know that's not the right domain. Okay, all the rest of them have the correct domains. It's the ranges that are the issue, right? So we want to go from -3 up to infinity because that's what if you smashed them all onto the x or to the y-axis, that's what you'd end up having. So -3 to infinity would be this one right here. Okay. Boy, I hope I get something else here. We will. Once again, they got a stupid looking domain right there. We know they're all negative infinity to infinity. I see you, kitty. Okay. Try not to claw my leg. That hurt before. Well, once you start pushing all of these points onto the y-axis, this is what kids, and this is where I talked about turning the graph at a 90-degree rotation, because in a clockwise fashion, so that you're seeing something that would look like this, with this being -8, because most kids realize that negative infinity would be over here, -8, and so they would get the idea that they need to go from negative infinity, stopping at -8. So you're really, you're starting here and you're coming up to -8 and stopping. In a vertical fashion, when you're looking at those things, sometimes it's hard to see. When you kind of twist the graph 90 degrees, it's easier to see the negative infinity to -8. Okay, is that it for that one? Yep. All right. That was a short one, so hopefully the next one won't be too bad either.